Okay, so the next thing is basically about the processes that it remains. Okay, so about the processes, so it remains only three things that I should basically complete. So first of all, zombie process, orphan process, and also the waitpid function. Okay. But so let me ask you first of all that. Okay, so do you know what is a zombie process?
Yeah.
Yes. Okay. So what is a zombie process?
A process without parent.
A process without parent is a zombie process. An orphan process?
Zombie process is when you kill the process. It's killed, but it's trying to run again or something.
So if it's killed, so how can be run again?
I don't know. It's
Okay,
it's
so
just
it's one
like
of
zombie.
Yeah, it's the orphan without parents.
Okay, so what was that?
If the parent is not waiting for the child, then the parent die and the child continue.
Somehow, but because if the okay, so but somehow is much more close. Okay, so anybody else? So no idea for the zombie process. Okay, so the zombie process, somehow your answer was okay. So the zombie process is just in this situation. If the parent is not waiting for the child process, till now is okay. So if the child process just terminates, so it go to the zombie state. Okay, till basically actually it send the sick child to the parent. So in this way, because the parent is not waiting for the child, so in this way, basically the child it goes to the zombie state, okay, and it's just remain there. Is killed is a kind of death process. Is killed, but so we cannot do anything for them. Is
there?
No, it's not there. It's killed. It's totally killed. It's a death process. It's killed. But you cannot do. But the only things that is okay regarding to the zombie process is that is using basically some resource. I mean the bad things for the zombie is using some resources from the system. Maybe the resources that is using is not that much. We say that okay, it's not that much resources that it because it's totally dead. Okay, so we cannot send the sick kill to the zombie process. But yeah, but the metadata information of this basically process is just there. I mean, it means that it has an entry inside of the process table. Okay, so it's just there. But so maybe according to this is not good. Okay.
But it is already dead himself.
But it's already dead, so you cannot say CC. But your answer was not okay because for the second part of your answer, you said that if the parent dies, basically. So also the zombie process, all of the zombie processes regarding to this basically to this parent, all of them will be released. Okay. But why is released? Because the parent is basically died, and then all of the zombie process regarding to this parent, so it goes to the init process, and init process handle them, and after that, okay, all of them just released. Okay. So one of the solution that when you have the zombie process is just killing the parent, and after that, so you will basically all of the zombie process will be released. Okay, but I give you one example of the zombie processes that okay. So we try to check that how we will have this zombie process. Okay, so this is so this is just one example, very simple example. Okay, I'm just creating one process here. And okay, so this part is just using by the parent. I'm just here. I'm waiting. So it's just I'm sleeping without waiting for the child. Okay, so it's just there. And after that, what for the child? I'm just exiting. So immediately the child exits, but the parent is just there, but is not waiting for the termination of any child.
So it does not know that.
So it means okay. So this situation is just exactly as a zombie process. So let's see that. Okay, how basically this work. Okay, so. Okay, so so this is a process. I just write a script in order to see the status of the zombie process. I give the name, and so it lists for me the status. So as you can see here, okay, PID, PPID, a status, and also the command. So the command is zombie, and actually this is the child. So as you can see, this is basically the parent is just the PID of this one. Okay, so this is the second one is the child of the first one. But as you can see here, the status here is just a zombie process. Okay, but if I'm going to just release myself from this situation, is just I cannot do anything, just killing the parent process. Actually, if I want to release this zombie process. Okay. So let. Okay, so anyhow, there's nothing. Okay, so also the zombie process will be just released from the system. But the solution in order to avoiding basically creating the zombie process. So here, okay. So first of all, I can just simply put wait. Collect the. So as you can see here. Okay. And then, as you can see here, I don't have zombie process because I just wait, and then so the wait basically collect the sick child signal that comes from the child, and so we don't have. This is one solution. And another solution is just okay. So this is one solution. Another solution is that okay. So you try to handle the basically sick child. Okay. So maybe there are some scenarios that I'm not going to wait because the wait function is a kind of blocking function. If you call wait, you will block there till your child basically send a signal. Okay. So you collect that. But maybe in some scenario I don't need to wait. Okay, but there are some other solutions in order to avoid waiting. But okay, so I don't need to wait. So you can handle the signal by yourself. So as you can see, installing a signal handler here for a sick child. But instead of basically sending a handler function, you send basically sick IGN. So it's okay. You are ignoring the signal. But anyhow, so you receive the signal.
So you know that.
So in this way, so the child successfully send the signal, also receive there, and so everything will be okay. Okay, so this is this one, and then after that, okay, so I run. And as you can see again, in this situation, I don't have it.
When you ignore the signal that you receive, is nothing sent back that tells you that informs you that your signal is being refused.
But we don't have acknowledgement for that. We never have acknowledgement. Okay. No.
So just to clear everything. So in the first example, I have this parent who sleep for 60 seconds. The child is not able to. No one.
No. I just wait for some seconds there, but I didn't basically introduce any wait or something. Okay, so it was just waiting.
Just waiting.
Just sleeping, let's say.
Exactly. Okay. So the child, no one collects from the sick child, and so that's why we call it zombie, because no one.
Yes.
Okay.
And so
after 60 seconds, the parent exit.
After 50 seconds, so the parent exit. But so these basically seconds I introduce here, it can basically last much more longer, right? This is the body of the parents, right? But
in case when it ends, what happens? The child.
The parent will be basically terminated, and also after that, so the child will be the zombie process will be released.
Will be released and go to init.
Go to the init or maybe go to system
collects.
D and then collects.
And that collects, and that's why it's no longer zombie.
Yeah.
So for us, while the parent is sleeping, you can consider it as a zombie.
No, I just introduced the sleep instead of
Because
sleeping.
I'm referring to what he asked.
No, actually, I introduced the sleep in order to avoid the.
Overlapping.
Yes, for example.
Otherwise, it was not.
No, because if I just remove the sleep, so it's immediately the parent will turn.
That is correct.
Yeah, I want
But even though the father is sleeping, basically, he receives the sixth child because the children exist immediately.
No, it doesn't receive
Yeah,
six
okay,
child.
ignore it.
No, it doesn't ignore it. No, it seems that okay. So it's just like you don't care about this signal, okay? But you shouldn't. You should just through the weight, because it's inside of the weight. So you have the process in order to collect this signal, okay? Or maybe you through the installing the signal handler. So you try
ignore
to
it, but you have received it, so it's not as zombie.
no, you don't
for
receive.
them.
No, you don't receive that. But because if you receive that, so basically you don't have a zombie process. You don't receive that yet. It's just like that. You don't have. It seems that okay. You don't have any solution for this signal. Okay, but here I just because I had a solution for this for a zombie process through the installation of this signal. Okay, and I was saying that okay, ignore that. In this case, even I didn't have zombie process. Okay, so I'm just ignoring.
Yeah. It's
So even it is not in this case, because otherwise I didn't have, I shouldn't have any zombie process, right? This is something that you say, but if without introducing this, basically the process ignore the signal, so I shouldn't have the zombie process. Even it doesn't ignore, it's just like doesn't care about that one. But here we have solution. We say that okay, ignore that. So we receive the signal, but the action for that signal is just ignored.
Yeah, it's what I was.
Yes, but you should install it.
Yeah,
we don't
otherwise
yes.
it's zombie.
Otherwise it's on. But okay, so another solution is that okay, anyhow, so if the parent is just killed, so
In that case,
yeah, so in the init process or maybe system D try to collect this basically the zombie process. So is that clear? So another thing is that okay, so you knew about the zombie process, but what about the orphan process? So who knows about the orphan process? Well, what is the orphan process?
the one that has no father.
The one that had no father. Okay, so
For example, a child that is still living, but the father has already terminated.
terminated. Okay, so if we have just first of all, if we have a process that basically generates a child, and after that just itself is just terminated, but still the child is there. So this is the orphan process. We say that okay, there is a child, but in this situation, when basically the parent is just terminated, so what is the solution? I mean, what will happen after? The init process will be the next parent for the child, okay? But actually it depends on the system, okay? So in some system that still is working with init will become the parent. But with some systems that they have the system D is the same as the init. So system D, it becomes the parent of the child. Okay. So let's have also one example regarding to the orphan. Okay. So here, again with the just very simple program here by the fork, I'm just creating one process, right? And after that here, I'm just verifying that okay. So this is the parent process. And after that, the parent, this is just the only thing that the parent basically does. So printing out parent process and then finish. Because it comes here and then return 0. So return 0, exit, underline exit, all of this stuff considered as just termination, okay? So after that, process will turn. But here, this is the part for the child, right? And then, okay, so the child basically sleeps basically for 60 seconds. But already the parent was disappeared, right? Was terminated. And after that print, okay, so I'm in the child process, okay? And after that terminate. But so in this situation, okay, so it is not a good basically program. So maybe you should handle also the termination for the child and this stuff. But this is just an example. I want to show the orphan process, okay? This is not a strong. Okay, so now, okay, the parent process is just died, and then here, so let's see. I have the basically the orphan process here, but okay, so, but okay, so as you can see, so the PPID of the basically orphan, it is not there. It seems that it's not in it. Okay. So I wrote the script here, and when I pass basically the PID here, I try to see the basically the ancestry of the process to see to the root. Okay. So first of all, the orphan is here, and after that, it goes to system D, and finally the system D1. So basically, this process is just is handling through the one of the unit of the system D. Okay. So that okay. So because this is handling the G terminal. Okay. This is the unit of the system D here. But anyhow, it does the same. So it becomes the parent of the process, and after that, okay. So this is the stuff. When it terminates, so it's just terminates. Okay. Any questions? Something? But it happens basically here. It happens when you are working with the system D, the systems that they have basically system D. Okay. So if you have some systems that they are working with the init, so still, but you see that exactly this is the parent is the init. Okay. Okay. Any question? Something? Okay. So let me was the whole things that I wanted to start today. Okay. So the last thing is just introducing the waitpid function. Okay, so the waitpid function, so it is it's a little bit more flexible comparing to wait. So because through the wait, you can just wait for the termination of the one of your child, and then you can basically collect the status. But here with waitpid, so you can basically wait for a specific child. And also basically through the options, so you can basically have much more flexibility for so even you can wait for not exactly for one process, so you can have much more flexibility. But through the wait, you cannot wait only for one specific child.
The wait waits for the
first child that terminates. But here you can wait exactly for one specific. Yeah.
So if you have several children and you generate them through a cycle, and you know the PID of each, you can do the waitpid to be able to wait for each of them.
Yes, with waitpid.
Yeah,
yes,
PID.
with waitpid.
Not with wait because
no, with wait. Okay, so you only wait for example, the first termination. Yeah.
If you wait for the last child, there are several childs. Then you wait only for the last one.
Yes.
You are waiting also
For the previous ones? No, because actually no. But what do you mean by the last one?
We were saying if I have several childs.
Yes, but he didn't say that. Okay, anything about the last or first?
No,
it's not
Yes.
a question.
No, I mean that. Okay, so yeah, because my question is that okay, what do you mean by first and last? According to the order of generating the four, because okay, so yeah, according to the order of generation, so you don't know the scheduler part for the termination. Okay. Okay, so this is the order. But also the another thing, because you talk about the order, about the signals. So when you generate some signals, you cannot guarantee the same order for receiving from that part. Okay. If you are using the default signals, you have also some type of signals that guarantees. But if you generate some signals, the order of the sending signal is not the same as the ordering of receiving signal.
Okay.
Okay. Okay, so but here so we have one very simple example. Okay, so first of all, creating the just one child, and after that, okay, so error handling here. But okay, so here we have a child, sleeping 1 second and then printing out something, then exit. But here in the parent side, so I'm going to wait for the PID. But because this PID is already basically assigned to the child process, so we are waiting basically for the child process and collecting the status. Okay, so let me first of all I give you the this example. Okay, and after that here, okay, the first one is just okay. You are waiting for which child, and then here is basically is the status that you can collect it from the child, and this is basically introducing some options. So first of all, I'm just giving nothing, no options here, and after that, sleep 3 seconds. I don't need this one anymore. Okay, so here, okay, simply this program is just from the child process, sleeping for 1 second, printing out something, but from the parent side, I'm collecting basically the status that I received, that it would be 3 here, and after that, okay, so verify that basically the child is terminated normally, and after that, printing out the status of the child, right? So this is the program. So let's okay, so child is going to terminate, so 1 second passed, and after that, so child exited with code 3. Okay, but so as you can see, we wait for something. So we wait here for 1 second for basically child, and also 3 seconds here for the parent, and after that I collect the stuff. But I'm going to introduce, for example, one option here. So as you see that I wait for the termination with wait or wait PID. I wait for the termination of the child, right? But it's possible that through some options you can introduce and you can say that okay, I'm not going to wait for the termination of the child process. But anyhow, you solve the problem of the zombie processes. Okay. So here, okay, but no wait. It means okay, instead of 0, it means that okay, you are not going to wait. Okay, and then immediately, so even here you can zoom. You can go. Okay. But actually, we need these 3 seconds here because otherwise, no, sorry, we don't need 3 seconds because okay, so if I don't introduce a sleep, so immediately I should terminate here. Okay, so immediately I terminate. Okay, so because I'm not waiting for the child. Okay, but so I need to basically wait a little bit here. Wait a little bit. First of all, child terminate, and after that, basically the parent terminate. Okay. But the point here is that I didn't collect correctly the basically the status of the child, right? Because it was terminated by 3, right? So because actually I didn't wait for the termination of the child, right? If you are going to do that, so here you need to call basically one more time status. Yes, you can try. Okay. So if you don't wait, that's okay. Don't wait. You do your stuff. But anyhow, at some point when you are going to collect the status, you call one more time wait, and you collect your status. Okay. Because actually here for the first time I didn't wait, right?
Yeah.
And then okay, so the child process terminates because I sleep here. I'm doing some stuff. And after that, so I try to again collect, but I collect the correct one for the second time. Okay. But if you just when you have only one time, so you don't wait, you don't collect the correct one, because because maybe that moment is not the moment exactly that your child process basically terminates. Okay. So you can go on. So you avoid the zombie process. You can go on, and after that, after some moment, you introduce one more wait, and then so it's okay. So you can collect the current.
What if I invert the sleep and the first waitpid? So if the child terminates, becomes zombie, no one is collecting, then the waitpid no wait will collect.
Okay, so you mean that I swapped the sleep 3 with the waitpid for second? Yeah.
The first one, the first waitpid.
The first waitpid with the sleep.
Yes.
Okay, that moment I suppose is okay because already you have the status.
Okay.
Yeah. But if but this is not the case because you don't know. Maybe you introduce wait, but it's not the moment that you don't know the when.
Is it certain because you can?
Yeah, now in this example, yes, but maybe that's okay. You can manage that.
Sleeping,
but in general, it's not okay. That okay.
For instance, if the child sleeps at the same time of the father, it's not said because it depends on the schedule.
Yes, depends on the scheduler and the system. But anyhow, so the point is just this point. The point is that if you are not waiting, so you are not collecting for the correct status. So maybe you can later basically issue one more wait and then collect the status. But anyhow, well, what is the option for the W no wait? It means that I'm not waiting, so it's not a blocking function, okay? But if you introduce 0 instead of no wait, it becomes a blocking function. You will wait, you will stop there till your child basically terminates, okay? Okay, so any questions, something? So is that clear? Okay, so if it's clear, so was the all of the stuff for today. Okay, thank you.